for that. Okay, let's continue. I was explaining something. Coming. I was explaining I was explaining how elements, they exist in existing in different forms. Like what I'm trying to say is that they have different forms of the same element. These are known as allotropes. Now we have isotopes, we also have allotropes. Allotropes are elements, they exist physically in different forms. Elements existing in different forms, but they are the same element. Do you get that?
Yes, sir.
Okay. All right, let's go to the next one. Now, since we know that, I think we should also be able to know, I guess we should be able to get the, let me share the screen again. You should be able to write the configuration of carbon, which is 1s2, 2s2, and 2p what? 2p4, right?
Yes.
Is it 2p4?
Um,
It's 2p what?
Two.
2p2, correct. Okay. So, having known this, the next thing we should be able to do is let's write allotropy. Right, allotropy is the existence of an element in the same physical state but different forms. Allotropy is the existence of an element in the same physical state but different forms. Now, those forms, an example of those form of allotropy is just look at yourself. You yourself, you exist in 3 different forms. You exist, number 1, as a soul, as a body, and as a spirit. Now, your body has to do with your physical appearance. Your soul has to do with your intellect. Your spirit has to do with your being. That is the real you. So, like I do tell my students that if I slap you, what part of your body am I beating? I'm actually slapping your body. I'm actually slapping doing harm to your body, not your soul. Now, we've been able to understand that carbon exhibits allotropy. Now, other elements that exhibit allotropy, we have sulfur. Please write. Other elements that exhibit allotropy include other elements that exhibit allotropy include other elements that exhibit allotropy include number 1, sulfur, number 2, tin, number 3, oxygen, sulfur, tin, oxygen, phosphorus. Now, the allotropes. Now we have allotropes of carbon. One of the allotropes of carbon we have is diamond and graphite. diamond, graphite, and charcoal. Diamond, graphite, and charcoal. Diamond, graphite, and charcoal. Okay, now please write, diamond and graphite are the two crystalline allotropes of carbon. Diamond and graphite are the two crystalline allotropes of carbon. Now, but when it comes to charcoal, charcoal is the amorphous allotrope. Charcoal is the amorphous allotrope. Okay, did you get that?
Yes, sir.
Okay, awesome. Now, let's start with diamond. Let's start with diamond. When we talk now, coming. Okay, now when we talk about the diamond, diamond has an octahedral.
So you're muted.
Hello? Hello? When we talk about,
Okay.
I said diamond has an octahedral structure. Was that where you stopped? Hello?
Yes, sir.
Okay, now I said diamond has an octahedral structure. Now, the rigidity, now write this part. The rigidity of the structure of diamond,
The diamond has a what structure?
octahedral structure. Have you written that?
Yes, sir.
Okay. Now, the rigidity of the structure, right, is responsible for the hardness of diamond. The rigidity of the structure is responsible for the hardness of diamond. The rigidity of the structure is responsible for the hardness of diamond. So that's why we see that diamond is said to be the hardest substance. Diamond is said to be the hardest known substance because they are held together by strong covalent bond. They are held together continuously, just as if you somebody comes into a trap, like a net trap, and the person cannot come out. So diamond structures are held, they are bounded together by covalent bond. Have you guys done bonding?
Yes, sir.
Okay, awesome. Now they are held together by strong covalent bond, and thus you see the molecules are compact together. That makes diamond the hardest known substance. All right. Any substance that okay, one of the things also we should know about diamond is that the melting point of diamond is very, very high. The melting point of diamond is very, very high. The melting point of diamond is very, very high. Okay. Now, let's continue. Let's look at the physical properties of diamond. Physical properties of diamond. Number one, the physical properties of diamond. Pure diamond is hard, it's colorless, and it's transparent. Core diamond, that's pure diamond, sorry, is hard, is colorless, and it's transparent. Okay, number two, they form octahedral crystals. They form octahedral crystals. That means 8. Octahedral is 8. So they form octahedral crystals. Number three, it does not conduct electricity. It does not conduct electricity. In fact, this is a very common question they ask. That because when we come to graphite, graphite conducts electricity and diamond does not conduct electricity. And they're going to be asking you questions that, why would graphite conduct electricity? Why cannot diamond conduct electricity? Yet they are from the same parent called carbon. Now, why diamond does not conduct electricity is because all the 4 valence electrons are used in bonding. All the 4 valence electrons are used in bonding. That's what gives it a hard shape, the octahedral shape. All the 4 valence electrons are used in bonding. Therefore, there is no mobile electron. That means they don't move. The electrons do not move. An example of such is like a stone. A stone cannot conduct electricity because all the electrons are used in bonding in a stone. So because of that, no electron flows in a stone. So that's a similar example. That's why diamond cannot conduct electricity. Now, the next number is it is insoluble in any solvent. Diamond is insoluble. Diamond is insoluble. Hello?